Saxon Advanced Mathematics, Lesson 67. Today we are going to talk about antilogs. Oh, that's a scary looking word, isn't it? Instead of saying anti-logarithms, we typically say anti-logs, or as I prefer, these are simply the numbers. All right, let's review what in the heck I mean by that. Let's start from the beginning. Here's an exponential equation that's super easy for us to remember. 10 to the third power is 1,000. Now, how do we write that in a log format? Well, we say that the exponent that you put on 10 to get 1,000 equals 3, right? Those are the same things. We've got a base here and here. We've got an exponent here and here. And then the last component is what I call the number. It can also be called the antilog, but that just freaks everybody out. This and this are the quote-unquote numbers. Now, up until now, we have been working on taking a number and finding the exponent that we put on the base in order to make that happen. Today, we're going to flip it around, and we're going to say we know the base and we know the exponent. How do we find the number? And in order to do that, I want to refresh you on the 4 keys of the calculator that we use for log calculations. So I don't have my calculator in front of me because it is currently being a camera. So here are the 4 buttons on a scientific calculator that you're using for these operations. Remember, we don't need a graphing calculator. That's the kind that has a big screen that can make a picture. We don't need those right now. We're just using a scientific calculator that has log functions and trig functions on it. And the best place I know to find that is on your phone if you've got a smartphone. And of course, they're all over the internet if you want to just look online. Okay. These are the 2 buttons that help us when we know the exponent and we want the number, okay? As opposed to these 2 buttons, which look completely different but work exactly the same except for different bases. These buttons are what we use when we know the number and we want the exponent. Please make sure, just like everything else I write down, copy this into your notes because it will make using your calculator so much easier, okay? This obviously is for the base of E, which is 2.718 if you write it out, okay? It's a long irrational number just like pi, but it's super useful for scientific calculations, engineering calculations, some financial calculations. So that's why it has earned a set of buttons on our calculators. This is good old base 10, which is commonly used for calculations in mathematics, all right? Our number system is base 10, right? We have 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, not 10. 10's a combination of other symbols. We have 10 symbols, that's why it's base 10. Probably we use base 10 because we have 10 fingers. Okay, so these are the buttons that are available. I've written the same information here on this page so that I can bring that with me as we move past this page. But this tells you how to use the buttons on your calculator, what they're good for, all right? So we're gonna refer back to this as we go. Let's look at our first problem. How many problems are there? They're really fast little problems. There are 5. Okay, so example 7.1. Ready? 67.1, sorry. I took us back 60 lessons. If the base is 2, I'm going to write it down just so we can look at it. Okay, if the base is 2, find the antilog, the number of 4.63. This must be the exponent, because we've already got the base and the number figured out, so this is the only other number. So what this problem is asking us to do is calculate 2 to the 4.63. Huh. All right. We can do that on the calculator. We'll have to use a different button because this base is not E or 10, but that's okay. We've got the tools to do that. But first, we want to estimate what this will be. We can be pretty sure that this is going to be the value of this will be somewhere between 2 to the 4th and 2 to the 5th, right? Because 2 to the 4.63, it's in between these two. 2 to the 4th is 2 times 2 times 2 times 2, which is 16. And 2 to the 5th is 1 more, which is 32. If you've ever played the game on your phone, 2048, it's all about powers of 2. You're combining tiles that keep raising you to a higher level. I love that game because it's really good at getting you strong on your powers of 2. Okay, so 2 to the 4.63 is going to be somewhere in between these two numbers. So we would expect our answer to be between 16 and 32. That's our estimate, okay? So now we take our number and we go to our calculator. This one, because it's not, we want to use a button like this, only we want to have the base of 2. It's not on our calculator, but there is a button that allows us to customize, and it looks like this. So the way it works is that you enter your X value, so we would enter a 2, right, because that's our base. And then we would hit this button, X to the Y, and then we enter our third number, 4.63, and then I believe we tap equals. And what you should get for your actual calculation, this is our estimate over here, right? For our actual calculation, we get 24.76. And that falls very nicely within our estimate. So we accept that as a good value. John is really big on this idea of estimate before you calculate, and I agree with him, because once we start pushing buttons on a calculator, all of our math common sense goes flying out the window. It happens to all of us, John and myself included. We stop thinking about the calculation and we just think about pushing buttons, okay? That is the fatal flaw of calculators, is that we stop thinking about math and we're just pushing buttons, trying to make it work. And so that's why John always emphasizes this process of estimate before you calculate, because then we have a reference point, and when we do get a value, we can evaluate it and see if it makes any kind of sense. These problems are super easy to estimate and answer because we can just round that that exponent to a whole number, and that gives us a nice little range. Okay, another problem. (67.2). This time, it says use a calculator to find the anti-log of 4.63 if the base is 10. I'm writing these down just so we can talk about them. You don't have to do that. All right, we're supposed to find the number of this. This must be the exponent, and that's the base, okay? So 10 to the 4.63, we're being asked to evaluate that. Oh, okay. Well, again, we can do a nice little estimate. 10 to the 4th, well, that's a 1 with 4 zeros. And 10 to the 5th, that's a 1 with 5 zeros. Okay? Now, that's a pretty big range. 10,000 to 100,000, because our base is so big, right? Just going up one step in our exponents creates a much bigger number because we're multiplying everything by 10. But we don't care because it's easy. Okay, so there's our estimate. Now we're ready for our actual. This time, the base is one for which we already have a button set up. So we don't have to use that generic XY, X to the Y. We can use this button. We know the exponent, we want the number. So we enter 4.63 and then hit this button, and it should come up right away. I don't think you have to hit equals for this one. And our actual value is 42,657.95. That falls within our range, and so we happily accept it as a good answer. Okay? Beautiful. Remember that the reason we used a different button, we could have used that X to the Y button again, but our calculator's already set up to give us powers of 10. So we don't have to use the custom button, customizable button. Whereas last time the base was 2, and we don't have a base of 2 button, right? We just have E and 10. So that's when we use the X to the Y. Okay. 67.3. Use a calculator, Use a calculator to find the base E anti-log of 4.63. So the exponent is still 4.63. We're changing the base to E, so that means we have E to the 4.63. Okay, so first we took 4.63 as an exponent on 2, and then we put it on 10, and now we're going to put it on E. Ugh. Well, how do we estimate that? Well, E is 718? So let's round this to 3. That's the closest whole number, right? So we're going to use a base of E to estimate for E, and then this will go down to 4 and up to 5. Now this is going to be a little rougher of an estimate because 3 is not exactly the same as E, but it's fine. It gives us something to go by. 3 to the 4th power, that's 9 times 9, that's 81. And then we multiply it one more time by 3 to get 3 to the 5th, and that is 3 times 8 is 24, 3 times 1 is 3, okay? So there's our range. It's gonna be between 81 and 243. Let's use our button to do the actual calculation here. Right, this is our estimate. I'll write this again. I've been putting this in a puffy cloud. Okay, actual, We're trying to find the value for this. We know the exponent. We want the number or the antilog. So that takes us back to this row of buttons, base of E this time. So we enter 4.63, then hit this button, and our actual value should be 102.51. That's the value of E raised to that power. And yeah, that fits nicely in our range. Beautiful. The next problem is really just a reference, and it's a great one. So keep this one in your brain. Write the value of E to 5 decimal places. Okay. Here's the thing about E. It's kind of like pi in that we know that letter stands for a number. In that way, it's exactly like pi. But unlike pi, which most of us can remember, it's 3.14, blah, 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 blah. It's hard to remember what E stands for because we rarely need to use the actual number in the calculations. So students often forget, I don't know what E is. So what we do is we enter 1 on the calculator, and then we hit that. That's instructing the calculator to use an exponent of 1 on E, and that will give us the value of 2.71828. Sometimes you have to hit equals after. I'm going to say you do. If the number jumps out at you, you don't. Not every one of these calculators, the software is a little different from one to another. So 1 e to the x equals, and then you'll get the whole big long string as long as your reader can tell you. That is the actual number. Okay, so it happens all the time that we forget what are the decimal places for that number E. Just enter 1 as the exponent and you'll get it. All right, one more. Estimate antilog minus, this is what they say. Estimate, and then they write antilog. And then there's a little E down here. And then it says minus 3.2. Well, that looks hard. But what that's saying is find the number with a base of E and the exponent of minus 3.2. So we can rewrite this into something that we like much better. Like so. And again, we want to estimate before we calculate. So what I'm going to do is I'm going to say it would be like 3 to the minus 3, and that would be 1 over 27, right? Because this is a negative exponent, so it's going to pop it down. And there's 3 cubed in the denominator. And then I grab my calculator, and I'm just going to divide 1 divided by 27, and that equals 0.037. So that's my estimated value. I'm not going to do a range this time. I'm just doing the 1 because it's fairly complicated. That's my estimate. Now, to do the actual, I just enter 3.2, hit that plus minus button to reverse the sign, then use e to the x. And what you'll get is an actual value of 0.040762 is as far as my calculator takes it. All right, this is pretty darn close to that, right? This is 37 thousandths. This is 40, if we rounded it, 41 thousandths. That is a pretty sweet estimate. And we can feel very good about that. Okay? So, when you hear the word anti-log, just remember that anti-log equals number. And these are the buttons that we use. We know the base and we know the exponent or the log, right? I'm going to go back and add those words to the original definition. So we're mostly using these buttons. Let me just go back here to where we started. And add, yeah. Here, when we refer to the exponent, we can also call that the log. And when we refer to the number, we can also call that the anti-log. This is exponential speak. This is logarithm speak. If logarithm speak weirds you out, that's fine. Just speak exponential speak. And I will too, because it's easier for me to make sure you understand if I'm using the language I know you know, okay? So log and anti-log, just code them, just break them down, and it'll be fine. All right, that's all I've got for you. I'm sorry. I guess you'll just have to have fun doing the homework without me. Well, I could do it, couldn't I? And one year I did that. I did the homework every week with my students so that I could kind of experience what that was like. It's a lot of work. And I was mean to myself and I made myself do every single problem. And I did a lot of problems that year. And I have newfound respect for what I don't want to say a drag it is, but it's a lot of work to do math homework every night. I am totally sympathetic to that. So all I can tell you is that what I'm doing is I'm trying to break this down enough so that you can teach yourself. Because the truth is that I can't teach you this math. No one can really teach anyone anything. We all have to learn for ourselves. Doing the homework is where you are actually learning how these ideas work. I'm just trying to kind of open the door enough so that when you encounter this in your homework, you'll kind of have some tools in your head as to how to approach it. But I'm not teaching you, you're teaching yourself. And that is the beauty and the value of the homework. All right, I'm done. Goodbye.